Hello and welcome to the very first video of the Algebra 1 tutorial series. Today I'll be covering lesson 1.1, which is solving simple equations. Before we begin, I'd like to introduce the resources I'll be using, primarily the Big Ideas math textbook. So Big Ideas actually offers easy access to all their textbooks through their website, which is linked right here, or you can find it in the description box. Go ahead and navigate to their website, then go to the Easy Access Materials drop menu. And for this lesson, I'll choose Algebra 1 for my grade, and then for the state, California. We'll go ahead and be directed to this menu of textbooks, and go ahead and choose your textbook. I'll be using this purple Algebra 1. Go ahead and click on your textbook and choose your chapter. I'll select chapter 1 and then choose your lesson. For today's lesson 1.1. Now for the actual lesson portion of today's video, as I introduced earlier, today we'll be learning how to solve simple equations. Now there are a few properties that you're going to have to know and able to solve simple equations. Usually they'll be worded like this. However, it's really just doing the opposite or reversing the algebraic operation that you're given. So in the instance of the addition property of equality, if you're given a simple equation like this, y minus 8 equals to 19, and you want to find your y value, you're going to have to add 8 to both sides to cancel the subtraction of the 8 from our y value. So it'll look like this. You'll add 8 to both sides. The 8 on the left side will actually cancel, and then 19 plus 8 will equal to 27. So you can see here that your variable is isolated on one side and that it equals to the value 27. If you were to plug this value back into the original equation, you'd see that they equal to one another. So 27 minus 8 would equal to 19. So you know that it checks out. Same goes for the subtraction property of equality. Let's say we have the same exact equation, except you're adding 8 to both sides this time. You're gonna go ahead and solve this by reversing your addition of 8 here by subtracting 8. So your 8 cancels, and then 19 minus 8 equals to 11. Your variable is isolated, and you get that it equals to 11. Once again, if you were to plug it back into the original equation, you'd see that the left side and the right side equal to one another. So 11 plus 8 would equal to 19. So let's go ahead and look at some objectives for today's lesson. To solve for x in the equation x minus 7 equals to negative 6, your goal is to get x alone on one side of the equation. You're going to do this by doing the opposite of whatever is keeping x from being all by itself. So for example, in this equation, we can see that the subtraction of 7 is keeping x from being all by itself. So we're going to do the opposite of subtracting 7, which is adding 7. And if you do that, your 7s cancel and you get x equals to 1. For example, once again, we have x plus 3.4 equals to 0.5. We can see here that 3.4 is keeping x from being by itself and that it's being added. So you would just subtract 3.4 from both sides. And the 3.4 here cancels. Subtract 3.4 on the right side. And 0.5 minus 3.4 equals to negative 2.9. X is finally all alone. So this is our solution. Let's go ahead and see our first example. We're given that h plus 2 pi equals to 3 pi. Now looking at pi, don't think it's the 3.14 value. You don't have to multiply anything. Just think of pi as a variable in this certain example. So we can see here that our unknown variable is h, and that our addition of 2 pi is keeping h from being by itself. So to undo this, we're going to go ahead and subtract 2 pi from both sides. The 2 pi's here get canceled out, and then h is all by itself. 3 pi minus 2 pi on the right side will just equal to pi. So your solution is h equals to pi. Let's go ahead and look at example 2. We're given x plus 1/2 equals to -3/2. So we can see here that we'll be working with fractions this time, but thankfully we're given common denominators, so there aren't any additional steps that we'll have to do. So we can see here that x is prevented from being alone by adding 1/2. So to reverse it, just subtract 1/2. 1/2 here cancels, and then you're given on the right side -3/2 minus 1/2. X is left alone, and then once you do this right side, -3 minus 1 equals to -4/2. You can go ahead and reduce that to -2. So x will equal to -2. Let's go ahead and look at another example. We're given m plus 2/9 equals to 2/3. Unfortunately, we don't have common denominators in this example, so we're going to go ahead and have to look for one. We can see here that we have 2/9 here and 2/3. Common denominator would be 9, and 3 times 3 would equal to 9. So your new fraction for 2/3 would be 6/9. Now that you have fractions with common denominators, you can go ahead and work this out. So once again, our addition of 2.9 is keeping our unknown variable m from being isolated. So we're going to undo that by subtracting 2.9 from both sides. Once you do that, you get m equals to 4/9. Let's go ahead and look into our last two properties, which is our multiplication property of equality and the division property of equality. Once again, as I was saying, they're usually going to put it in fancy wording like this, but you're really just reversing whatever operation you're given to isolate your variable. So let's go ahead and look at an equation like this. 8x equals to 96. We can see here that x is being multiplied by 8. And to undo multiplication, you're going to have to divide both sides by whatever value is keeping x from being by itself. Same goes for if you were dividing anything by 8, you would multiply both sides by 8. So let's go ahead and see how we do this, solve this equation. So our objective is to isolate the variable on one side of the equal sign. We need to know what 1x is. So divide both sides of the equation by the exact same number as the coefficient. The coefficient is just the number that is in front of the variable. So to do this operation, you would have your equation 8x equals to 96. Isolate x by dividing both sides by 8, and then you get that x equals to 12. Let's look at this example. We're given 5x equals to 30. It's very similar to the previous example before. You're just going to go ahead and divide both sides by 5. So divide both sides by 5. Your 5's on the left side cancel out, and you get that x equals to 6. Another one, like the previous one, we're given -7x equals to 49. Go ahead and divide both sides by -7. Your -7's on the left side cancel out, and then 49 divided by -7 equals to -7. So your x value equals to -7. Another one involving pi. Again, don't worry about pi. Just think of it as a variable. So we have pi x equals to 3 pi. We can see here that pi multiplied by x is keeping x from being by itself. So simply divide both sides by pi. Your pi's on this left side cancel out and x is isolated. Then 3 pi divided by pi would just be 3 since the pi's cancel one another out. So your final answer would be x equals to 3. Now for something different. We have y over 4 equals to -7. Recall that you're really just reversing whatever operation you're giving to isolate your variable. So in this case, if you have y over 4 equals to -7, you're going to multiply both sides by 4. So you can see here that your 4 is going to cancel out on the left side and you're left with y. So y equals to -7 times 4. That would give you y equals to -28. Okay, let's go ahead and look at something different. So to solve an equation like 3/4 x equals 12, you're going to multiply both sides of the equation by the reciprocal of the coefficient. Once again, the coefficient is the number in front of the variable. So to cancel the 3/4 that is preventing x from being by itself, just multiply by the reciprocal, which is just the fraction switched around. So in this case, it would be 4/3. You can see here that 3/4 and 4/3 will cancel one another out. So you're left with just x. And then 12 times 4/3 would equal to 48 over 3. And your x value would equal to 16. Let's go ahead and do a few examples that are similar to the previous slide. So we're given here that 3/8 equals to -5/4 x. As seen in the equation, our -5/4 is preventing x from being by itself. So we're going to multiply the reciprocal, or -4/5. So our -4/5 and times our -5/4 would cancel one another out. And then you would have 3/8 times -4/5 on the left side. And that would give you 12 over -40 equals x. You can actually reduce this equation by a factor of 4, and that gives you -3/10 equals x. Another one very similar to the previous slide, we're given that 5/6 equals to -2/3 x. -2/3 is preventing x from being by itself, so just multiply by the reciprocal. That would be -3/2. So -3/2 and -2/3 would cancel one another out, and you're left with x by itself. Now for the other side, you're going to have to simplify this, and you get 5/6 times 3 over -2 equals to 15 over -12 equals to x. You can actually reduce this fraction by a factor of 3, and that would give you -5/4 equals to x. Okay, let's go ahead and look at a real-life application problem. We're given that the melting point of a solid is the temperature at which the solid becomes a liquid. The melting point of bromine is -7 degrees Celsius. The melting point of bromine is 1/30 of the melting point of nitrogen. Write and solve an equation to find the melting point of nitrogen. So when you're looking at a word problem like this, always focus on what values are already given. In this case, we're given that the melting point of bromine is -7 degrees Celsius, and that bromine, the melting point of bromine, is 1/30 of the melting point of nitrogen. So we're trying to first we're trying to write an equation, and then solving that equation to ultimately find the melting point of nitrogen. So let's go ahead and take this information and create an equation first. We're going to go ahead and create a variable for our unknown value, which is the melting point of nitrogen. You can use whatever you'd like. I'll go ahead and be using n, and we're going to let the variable n represent the melting point. We know that the melting point of bromine is -7 degrees Celsius, and that melting point, which is -7, is 1/30 of nitrogen's boiling point. So let's go ahead and set up our known value, which is -7, to whatever we have on this right side. So we have bromine's melting point will equal to 1/30 of nitrogen. Once again, bromine's melting point is -7, and our boiling point of nitrogen is represented by the variable n. We're given that bromine's melting point equals to 1/30 of nitrogen's, so we would set -7 to 1/30 n. Now, similar to the previous problems, we're going to have to multiply both sides by the reciprocal of our fraction. In this case, just multiply both sides by 30. 30 and 1/30 cancel out, and then 30 times -7 would equal to -210 degrees Celsius. N is isolated, so you finished all solving the equation, and you can put as your solution that the boiling point of nitrogen is -210 degrees Celsius. You can go ahead and pause the video and try these problems for practice if you'd like. Here are the solutions for the problems, and I'll go ahead and work these out for you guys. So the first one is b plus 2 equals to -5. The addition of 2 is keeping b from being isolated. So I'm just going to go ahead and subtract both sides by 2. If you do that, -5 minus 2 would equal to -7. So b equals to -7. For letter B, we're given -3 equals to k plus 3. Plus 3 is keeping k from being by itself, so subtract both sides by 3. And -3 minus 3 equals to -6, so k will equal to -6. For C, we're given t minus 1/4 equals to -3/4. Let's go ahead and add both sides. Add 1/4 to both sides, since the subtraction of 1/4 is keeping t from being by itself. If you add 1/4 to -3/4, you're given -2/4, and 2/4 can reduce into -1/2, so t would equal to -1/2. For D, we're given 7x equals to -35. The multiplying of 7 to x is keeping x from being isolated, so just divide both sides by 7. -35 divided by 7 equals to -5. X is isolated, so your solution is x equals to -5. For letter E, we're given that 3/2 equals to 9/10 k. The multiplication of 9/10 to k is preventing it from being isolated. So I'm going to go ahead and multiply both sides by the reciprocal of 9/10 to cancel it out. So the reciprocal would be 10/9, and then that would cancel out. K is isolated, and then multiply 3/2 by 10/9. You're given that k equals to 30/18, and you can actually reduce this by a factor of 6, which would just be k equals to 5/3. Lastly, we have letter F, which is 6 equals to -w/8. If you see there's no value in front of the variable, just assume that the number is 1. So this would just be 6 equals to -1/8 W. We can see here that -1/8 is keeping W from being isolated, so multiply both sides by 8/1. Go ahead and multiply 6 by -8, and we get that W equals to -48. Thank you so much for watching today's tutorial. If you're looking to request any certain concepts or lessons, I actually have a Google form open. It's linked in the description box, so you can go ahead and fill it out after this video if you'd like. Anything from pre-algebra to algebra 2 can be covered. For additional practice on this lesson, you can actually use the Big Ideas math textbook that I introduced at the beginning of this video. Go to chapter 1, lesson 1.1, and go select pages 7 through 9 and do the following problems. The solutions and how you work them out can be found in the description box. If you're looking for tutoring, I do actually offer one-on-one tutoring services. If you're interested, please feel free to email me or Google chat me at my email, kaylin.david24@gmail.com. And once again, that'll also be found in the description box. I'll try to respond as promptly as I can. Once again, thank you so much for watching today's video. And if you have any questions about what we learned today, go ahead and leave it in the comment section below. See you next time.